Hi friends, good evening to everyone. Welcome to my channel Belagali's classes. Yes, my friends, done in the previous video about what? Mean value theorems. One very important result is, first I just done it. What is it? Every polynomial function in X is a continuous function for all X. That is again useful here, my friends. Yes. The next theorem is Lagrange's mean value theorem, my friends. Lagrange's mean value theorem. Yes, my friends. So again, you have only statement of what? That mean value theorem. Lagrange's mean value theorem. Mean value theorem, my friends. Normally that Lagrange is never used. Simply they use it, and this theorem is popular by naming this as what? Mean value theorem. Simply mean value theorem. Yes, my friends. Once again, you have only its a statement. State mean value theorem. A function f is a statement, my friends. A statement at any moment time they may ask under 1 mark, 2 mark. It depends on examiner. You must prepare these statements also. A function f is such that, what is first? Fx is continuous in the closed interval. What is second? Fx is differentiable in the open interval. Only two conditions, my friends. Whereas in case of Rolle's theorem, you know the third condition. What is the third condition here? F of A equal to F of B. You mean F at both the ends equal, but it is not here. Only two. One is continuous, another is differentiable. If these two are true, by mean value theorem, there exists at least one point C in the open interval AB. Ends are not considered. Open interval AB such that Fb minus Fa upon B minus A equal to F dash C. Fb minus Fa upon B minus A equal to F dash C. This is the statement of what, my friends? Mean value theorem. What next, my friends? Just verifications. Means some examples to verify this mean value theorem, as we have done in case of what? Rolle's theorem. We have to do here. See, my friends. I start with examples. Verify the mean value theorem for the function fx equal to x square minus 4x minus 3 in the closed interval AB, where A is 1 first and B is 4 second, and then your interval is what? 1 to 4. Closed interval 1 to 4. Yes, my friends, you want to verify. Verify means first two, what they are. You have to verify the given conditions. First condition, fx is continuous. What is the second is? Fx is differentiable. Verifying these two conditions, then you must show what? The next is, there exists a point or at least one point C in the open interval AB with this property, my friends. What is that? Fb minus Fa upon B minus A equal to F dash C. Fb minus Fa upon B minus C equal to F dash C. This we have to verify. If this is true, it is true for what? A point in the open interval AB. It is a point in the open interval AB, my friends. This is the open interval AB. That point must be inside here. That point must be inside C. Yes, my friends. Already one example is dancing on the board. I will explain it. Have concentration. Listen. See, my friend. Verify this mean value theorem for this function in the interval 1 to 4. What is this, my friends? Once again, it is a polynomial in x. Every polynomial function is continuous. So, fx is continuous for all x. In particular, it is continuous in the interval 1 to 4. T subset of this x. Second, fx equal to this. X square minus 4x minus 3. Differentiate. Derivative of f is f dash x. X square 2x minus 4x is minus 4. As kx is k minus 4x is minus 4. Which is finite in the open interval 1 to 4. You mean you can give any value in the open interval what? Open interval 1 to 4. This f dash x is finite. When it is finite, we say that it is differentiable in the open interval 1 to 4. Differentiable. Now from this, continuity verified, differentiability verified. You have to write one line. Thus the conditions of the mean value theorem are satisfied. Hence, the conditions of the mean value theorem are satisfied. Yes, my friend. Then by mean value theorem, if the conditions are satisfied, see there. If these two conditions are satisfied, then there exists at least one point C with this property. Yes, my friends. So, by mean value theorem, there exists a point C such that fb minus fa upon b minus a equal to f dash. You have to verify this, man. Yes, you have to find fb minus fa. You have to find b minus a. Substitute. You have to find f dash c. Substitute. Find the value of c. That value of c must be in the open interval. In the open interval. That's we needed. See, my friend. This is fx. Now, this is fx. Fx. You wanted both the ends. F of 1. X is 1. X is 1 minus 3. Minus 7 plus 1 is minus 6. F is 4. 4 square. Minus 4 into 4. It is minus 3. 16 cancels with 16 gives what? Minus 3. F of b minus, my friend, this is f a. Okay. First end. What is this? F of b. Second end. F of b minus f a. You mean f of 4 minus f of 1. Minus, it is what? Minus 3. Minus with this minus is plus. Minus 3 plus 6 is plus 3. Then you have to find b minus a. 4 minus 1 c. b minus a. 4 minus 1 is 3. Then what is f dash x? F dash x is 2x minus 4. What is f dash is c, my friend. Replace x by c. It is 2c minus 4. F dash c is 2c minus 4. Substitute these values in 1. Substitute these values in 1. What is fb minus fa? 3. What is b minus a? Down 3. 3 upon 3 equal to f dash c. 2c minus 4. 2c minus 4. 1. 2c minus 4. Bring this side 5. 5 equal to 2c. Then what is c? 5 by 2. What is 5 by 2? 2.5. That 2.5 lies where? Well inside the open interval 1 to 4. Thus, what? Mean value theorem is verified. Thus, the mean value theorem is verified. Yes, my friends. These are lengthy. To write, they are lengthy, but they are simple theorems. But to write, they are lengthy. Yes, friends. This is one example. I give 1 minute time. Copy it. 1 minute time. Yes, copy it. Yes, friends. All right. I do one more example, then one example for practice. Practice. Yes, my friends. My friends. Verify mean value theorem. Verify mean value theorem for the function. Mean value theorem for the function f(x) equal to x cube minus 5x square minus 3x in the closed interval 1 comma 3 in the closed interval 1 comma 3. Again same lines, actually they are very simple, very simple. See, again it is a polynomial function of degree 3. What about the previous one? Degree 2. This is degree 3. Yes, you are writing. Fx is a polynomial function of x and hence it is continuous for all x belongs to R. Means real values, my friends, belongs to R. Implies it is continuous in the particular interval. What is it? Closed interval 1 comma 3. Yes, my friends. Next part. Right. What is f dash fx? Fx is x cube minus 5x square minus 3x. Differentiate with respect to x. See, my friend. What is f dash x? X cube 3x square minus 5 into 2 minus 3. I tell kx is k minus 3x derivative is minus 3, which is finite in the interval 1 to 3. Open interval 1 to 3 is finite. So fx is differentiable in the open interval 1 to 3. Thus the conditions of mean value theorem are satisfied. One is continuity, another is differentiability. Only two conditions satisfied. When the conditions are satisfied using mean value theorem, there exists a point C such that this fb minus fa upon b minus a equal to f dash. You name this as 1. Yes, friends. And then you have to find all these values. Yes, friends. Now you know fx. With the help of that you have to get ends. First end fa, second end fb. Yes, my friends, we know fx equal to fx is x cube minus 5x square minus 3x. X cube minus 5x square minus 3x. This end f of a. F of a is f of 1 cube minus 5 into 1 minus 3 into 1. Tell my friends. What is this? 1 minus 8. 1 minus 8 is minus 7. 1 minus 8 is minus 7. Next is f of b. F of 3. Second point 3 b. Cube 3 cube. Yes. Minus 9. 3 square is 9 into 5. 45. Minus 3 into this 3 is minus 9. Tell Fred. How much? This becomes 54. 54, which is 27 minus 54. If you simplify, it is minus 27. Minus 27. Therefore, FB minus FA. Therefore, FB minus FA minus 27 plus 7. Yes, my friend, it is FB minus FA, which is minus 27. Minus of minus is plus, gives minus 20. Tell what is B minus A, which is 3 minus 1, 2. See, difference of these two ends, 3 minus 1, 2. Then f dash x. F dash x is, my friend, 3x square minus 10x minus 3. Yes or no? Here, minus 3. You wanted f dash c. Replace x by c. 3c square minus 10c minus 3. Put these values in 1. Substitute these values in 1. Values in 1. Where is 1, my friends? 1 is here. Then you have to substitute in this, my friends. Substitute in this. Yes, right. Yes, my friends. So I will remove this. Oh, you copied this. You copied this. Yes, friends, I take this. Yes. F dash c equal to 0 gives. No, we have to put the values. Yes, my friend, what is FB minus FA? Minus 20. What is B minus A? 2. This is minus 20 upon 2 equal to f dash c. That is 3c square minus 10c minus 3. Friend, cancellation. Take that side. 3c square minus 10c minus 3 minus 10 becomes minus 10 becomes plus 10. RHS is 0. So my friends, 3c square minus 10c, it is plus 7 equal to 0. Plus 7 equal to 0. Tell friend. 3 into 7 plus 21. Split, you must get what? Minus 10. Then my friends, it is minus 3 minus 7. Minus 3 minus 7 product is plus 21. And what about the addition? Minus 3 minus 7 addition is minus 10. Yes, my friend. Simplify it. 3c square minus 3c minus 7c plus 7 equal to 0. 3c is common. C minus 3. No. C minus 1. Why? 3 is common. 3c is common. C minus 1. Minus 7 is common. C minus 1 equal to 0. Yes, my friends, it is C minus 1 into 3c minus 7 equal to 0. Tell. From this, the value of C is 1. From this, the value of C equal to 1. Is it in the interval? Yes, it is. No. It does not belong to the open interval 1 to 3. Why? Open means you know The C doesn't have 1 is 1. Therefore, C equal to 1 does not belongs to. And what is another value? C equal to 7 by 3. 7 by 3 is, my friends, it is 2.33. Yes. 2, 6, 1, 10 means 3. 2.33, which belongs to the open interval 1 to 3. Which belongs to the open interval 1 to 3. Therefore, theorem is verified. Therefore, theorem is verified. Theorem is verified. Verified. Yes, my friends. Copy it. Theorem is verified. Verified. Theorem is verified. Verified. Yes, friends. One sample example. Just you have to do it yourselves. Do it yourselves. DIY homework. Verify the mean value theorem for the function fx equal to x cube plus x squared minus 6x in the closed interval minus 1 comma 4. Minus 1 comma 4. Again, as usual, we must same steps. Get C, get it. At least 1 point will be always where in the open interval. In the open interval. That verifies what? The mean value theorem. Now, if anybody is interested, one more. Examine the applicability of examine the applicability of the mean value theorem for the function fx equal to 2x square minus 10x plus 29 in the interval 2 to 7, in the interval 2 comma 7. Yes, my friends, these are two examples. You have to do it yourself. One x cube plus x square minus 6x in this interval. Say fx equal to 2x square minus 10x plus 29 in this closed interval 2 to 7. Yes, my friends. These two, do it yourselves. Do it yourselves. Yes, my friend. Another one is, sometimes instead of mean value theorem, the friend will restrict, why it is lengthy, to restrict what? Find the values of C by using mean value theorem. Find C by using mean value theorem. At that time, directly find C means no need to verify what? The first two conditions. Directly, conditions are what? Already they are true, satisfied. Directly by the mean value theorem, there exists a point C, f dash C, my friends, f dash C. Yes, I do one sample of that type. Find the value of C. Hope these two examples copied. Examples copied. Find the value of C. Value of C. C in the applicability of mean value theorem. In the applicability of mean value theorem. Applicability of the mean value theorem. Mean value theorem for the function fx equal to 3 plus 4x minus x square in the closed interval 1 to 4. Yes, my friends. Already you know the applicability means what? No need to verify for what? Continuity and differentiability. Again, it is a polynomial function, naturally continuous, and f dash x exists where? In the open interval, then differentiable. Yes, my friends. Then you have to find this. Right. By mean value theorem, you have this. Right. By mean value theorem. By mean value theorem, we have fb minus fa upon b minus a equal to f dash c. Name this as 1. Yes, my friends, you have to find these values. What is fx? 3 plus 4x minus x square. Find both the ends. What is the interval? 1 to 4. F of a first. First end 1. 1 is what? 3 plus 4 into 1 minus 1. 7 minus 1 is 6. Then second end f of b is f of 4. Yes, 3 plus 4 into 4 minus 4 square plus minus cancelled 3. Find fb minus fa. fb minus fa. fb 3 minus fa 6. Simplification. Then b minus a. What is b? 4. A 4 minus 1 is 3. Then comes f dash c you wanted. Fx first, then derivative. Fx is, my friends, it is 3 plus 4x minus x square. F dash x is what? 0. 4x is 4 minus x square is 2x. You wanted f dash is c 4 minus 2c. Replace your x by c here. X by c, x by c. Yes. Substitute these values in 1. Numerator minus 3, denominator plus 3, RHS 4 minus 2c. 4 minus 2c. Substitute these values in 1. These values in 1. Numerator is minus 3 plus 3, 4 minus 2c. It is minus 1 equal to 4 minus 2c. This side 2c equal to minus becomes plus, which is 5. What is the value of c? 5 by 2, which is 2.5. 2.5. Is it well inside the open interval? Yes, my friends. It is greater than 2, less than 4. It is greater than 1 and less than 4. You mean this value of c belongs to where? Lies well inside the open interval 1 to 4. 1 to 4. This is the value of c by making use of what? Mean value theorem. Mean value theorem. Here they may give some very simple examples, and also you must be very quick. May give under what? CET also. CET also they may give such finding the value of c either by what? Rolle's theorem, otherwise by mean value theorem. Mean value theorem. Yes, my friends. This is the method of finding c using mean value theorem. Finding c using Rolle's theorem also may where in CET also you may get. Copy it. Yes. Friends, I do one more. The last example on this. It is a good example. It is a good example even for CET also. Good example. Yes, my friends. That last example is examine the mean value theorem. Examine the mean value theorem. Examine the mean value theorem. Mean value theorem. Theorem for the function fx equal to, my friend, what is this? Bracket function. Bracket function means greatest integer function. What is the definition? That the greatest integer function is always integer less or equal to x, where it is also called as bracket x, where greatest integer function, GIF, where bracket function is the greatest integer function, which is an integer It is always integer, my friend. Less or equal to x, my friend. It never be greater than x. It is either equal. For example, my friends, here bracket 2. What is this? It is integer itself. Is 2. Bracket 2.5. Tell my friend, what is this? It is not integer. It is a fraction comes here. So it is always integer. It is an integer less than 2.5. You can't write because it is an integer means what? Always you must write integer itself. This is your interval. This is 2. This is 2.5. This is 3. 2.5 is here. You never write 3 integer. You have to write its values to itself. Yes, my friends. Tell. Is it applicable? Is mean value theorem is useful here, applicable here, applicable here. Tell. These are the two conditions. If you wanted to apply this mean value theorem, you must verify the function must be continuous in the closed interval. The function must be differentiable. My friends have not given the interval here. In the interval 5 to 9, closed interval 5 to 9. This is 9. This is 5, my friends. Our concentration is where? On the integers itself. 5, it is an integer. Integer in between what? 5 to 9, these are the integers. Already while doing the continuity of a function, we proved it, we shown it. What is that? Bracket function is a discontinuous function at integral points. Integral points means at integer. What are the integral points in between? 5, 6, 7, 8, 9. Then what about your bracket x? It is not continuous at that point. Then the first condition itself fails to exist. When the first condition fails, this mean value theorem is not applicable for this function. 2 lines, my friends. 2 lines. Yes. Yes, we know that. We know that. We know that fx equal to, it is the greatest integer function, is discontinuous at all integral points. Integral points means integers. At all integral points implies fx equal to mod x is discontinuous at integral points. What they are, my friends? 5, 6, 7, 8, 9, where they are from the closed interval 5 to 9. They are from the closed interval 5 to 9. Then when it is discontinuous at this, first condition fails, implies first condition fails. Fails to exist. When the first condition fails, implies mean value theorem is not applicable. For fx equal to bracket x. Yes, my friend. So, in this case, as the first condition fails, what is the first condition? Continuity fails, then mean value theorem is not applicable. Even what about the rules theorem? Again, the rules theorem also needs what? First condition is continuity. So, Even for the bracket x, greatest integer function, mean value theorem not applicable. On the same lines, even Rolle's theorem is also not applicable because it's part of what? Discontinuity. They need what? Function must be continuous inside the closed interval. Therefore, because of that first condition, we can't apply mean value theorem as well as Rolle's theorem also. Yes, my friends, these are some examples on mean value theorems. On mean value theorems, you have examples, normally either 2 mark, otherwise mostly 3 mark questions, 3 mark lengthy examples. Yes, my friends. This finishes your differential calculus, entire differentiation. I have done with what? Continuity part in the beginning. Then I have done what? Derivatives of all varieties of the functions. First, composite. Second, implicit. Third, inverse trigonometric functions. Fourth, logarithmic functions. Fifth, parametric functions. Sixth, successive differentiation. My friends, I have done one by one in series with them. Done most of the examples from your textbook, my friends. Very important examples. Only I have given DIY, do it yourself. Only the parallel examples, my friends, parallel. Just now completed with what? Statement of mean value theorems and their applications. That part is also done, my friends. This finishes that differentiation part. Next is either I have to do with application part, otherwise integration part. Just I will think of it. If I start with integration, I do it integration. Yes, my friends. Hope everything in differentiation will be clear. Even my videos are clear. Even you can clearly copy the notes also. Everything is written very systematically. Written and everything, my friends. Take the use of this. Refer them repeatedly. Then prepare the notes. Then you prepare for what? Your exams. Okay. Saying this, my friends. In the next video, saying what? Completes differentiation. In the next, I may start with integration, otherwise applications of derivatives. Either the one I will start. Yes, my friends. This part, this section, differential calculus, that is differentiation, is completed. Yes, my friends. Thank you very much. Prepare nicely. Yes. All right, my friends.